My name is Pengfei Wang. I'm from Zhejiang University. I'm glad to present our work, PromptEM, Prompt Tuning for Low-Resource Generalized Entity Matching. We'll introduce the motivation of our problem. Entity matching, EM, which aims to identify whether two entity records from two relational tables refer to the same real-world entity, is one of the fundamental problems in data management. Traditional EM assumes that two tables are homogeneous with the aligned schema, while it is common that entity records of different formats, example, relational, semi-structured, or textual types, involve in practical scenarios. In such a processing pipeline, we observe that there are three issues required to be solved. First, it is not practical to unify their schemas due to the different formats. To support EM on format-different entity records, Generalized Entity Matching, GEM, has been proposed and gained much attention recently. Second, the labeling process for entity matching tasks is extremely labor-intensive. Third, the current fine-tuning way for PLMs cannot realize the full potential of the model. To address above issues, this paper, for the first time, focuses on the low-resource GEM and proposes a novel low-resource GEM method, termed as PromptEM. Next, I introduce the related work. Due to the importance of entity matching, many methods are proposed. Specifically, they can be divided into two categories: non-pre-trained language models-based methods and pre-trained language models-based approaches. The former is limited to the representation ability since they do not utilize the recent advances in deep language models. The latter tries to represent tabular data by pre-trained language models. Recent studies try to introduce AI techniques to reduce dependency on labels for entity matching. Example, data augmentation and transfer learning. Overall, they focus on traditional EM instead of the practical GEM. Next, I introduce the preliminaries. Pre-trained language models such as BERT have shown powerful semantic expression abilities, which can support lots of downstream tasks. Concretely, we can plug inputs and outputs into a pre-trained LM based on the specific task and then fine-tune all the model's parameters end-to-end. The entity matching problem can be treated as a sentence pair classification task. In the following, we present our proposed framework. To cast the GEM problem as a prompt tuning one, we first designed suitable prompt templates, i.e., hard encoding templates and continuous templates, and label word set, to consider general binary relationship. As prompt construction is to find a method that allows a LM to effectively perform a task, rather than being for human consumption, it is not necessary to limit the prompt to human interpretable natural language. Thus, continuous prompts are proposed to perform prompting directly in the embedding space of the model. Here, we employ p-tuning, where continuous prompt tokens are learned by inserting trainable variables into the embedding input. In addition to designing templates, another primary component is to design the label word set. Note that traditional EM tasks find pairs of entities that are identical. However, GEM might require finding out entity pairs satisfying a general binary relationship. Taking paper matching as an example, our goal is to find pairs between paper metadata and abstracts. Indeed, the relationship between them is whether they are relevant, which is more general beyond matching. Considering general binary relationship, we map the label y equals yes into a set vy equals matched, similar, relevant. Similarly, the label set for label y equals no is vy equals mismatched, different, irrelevant. To further improve the performance and avoid expensive self-training, we develop a generic lightweight self-training method. Our lightweight self-training aims to boost the performance, i.e., effectiveness, using uncertainty meanwhile being more efficient and lightweight than traditional self-training via dynamic data pruning. Selecting high-quality pseudo-labels is a prerequisite for boosting self-training performance. A straightforward way to select pseudo-labels is by selecting samples with high-confidence predictions. However, incorrect predictions can have high confidence scores in poorly calibrated networks. Besides, if the teacher model already predicts some samples with high confidence, then these is little to gain for student model with these samples. Based on the observation that prediction uncertainties can be leveraged to negate the effect of poor calibration, we employ an uncertainty-aware pseudo-label selection strategy. Traditional self-training can be expensive as the training set grows, resulting in more training time. Recently, the error L2 norm AL2N score can identify important examples early in training. In other words, it can prune significant fractions of useless training data without sacrificing test accuracy, which can reduce the number of the training set and training time. Inspired by EL2N and MC dropout, we combine these approaches and propose MC EL2N, which is able to quantify important scores more stably. Here, we analyze the experimental results. We utilize 8 real datasets. This table summarizes the statistics. We compare PromptEM with 3 kinds of baselines, including conventional EM, low-resource EM, and unsupervised approach for structural and textual data. In addition, the metrics are precision, recall, and F1 score. We first verify the performance under low-resource setting of PromptEM using the above 8 baselines. The benchmark results of all methods across the datasets are reported in the table above. DeepMatcher achieves the worst performance. Since it does not leverage the recent advances in pre-trained LMs, existing low-resource EM approaches, i.e., Ditto, Dater, and Rotem, achieve relatively poor performance, because the GEM problem is more intractable than EM, example, heterogeneous tables. In particular, DeepMatch is not stable across different datasets due to the absence of label guidance. We also evaluate methods in a more challenging setting, i.e., the number of available data for training is only 80 for all the datasets. This setting is extremely challenging for supervised methods, example, only using 0.46% labeled examples on semi-homo. As shown in the table below, PromptEM achieves SOTA performance on most datasets, which demonstrates the great robustness of PromptEM compared to baselines. Moreover, it also shows the outstanding scalability of PromptEM, which achieves considerable performance only using a small number of labeled data examples. We reduce the training rate from 25% to 5% to see the performance under different low-resource settings. Experimental results are depicted in the figure. We observe that PromptEM achieves SOTA performance in most cases, while DeepMatch and Dater achieve unstable results across different datasets due to lacking the guidance of labels and the heterogeneity of datasets. We consider several pseudo-label selection strategies, including uncertainty, confidence, and clustering. We use true positive rate, TPR, and true negative rate, TNR, to evaluate the quality of the pseudo-labels generated by different strategies. As expected, uncertainty can achieve state-of-the-art performance when generating pseudo-labels. Example, TPR and TNR are 0.88 and 0.99 on average, respectively. It confirms the effectiveness of the uncertainty-aware pseudo-label selection strategy. Designing prompt templates is a primary component of prompt tuning. We verify the effect of different templates, i.e., continuous T1, hard encoding T1, continuous T2, and hard encoding T2. Their average F1 scores on all datasets are 74.4, 67.8, 77.0, and 74.5, respectively. Continuous templates achieve better performance than hard encoding templates. This further validates the effectiveness of the proposed continuous templates, which can find better continuous prompts beyond the original vocabulary could express. We compare our designed label words with a simple one, i.e., matched and mismatched. Using continuous T1 and T2, our designed label words achieve plus 5.2% and plus 9.4% average F1 score improvements over the simple one, respectively. This confirms the effectiveness of our designed label words. In other words, considering the more general relationship between entities is beneficial to the predictions. At last, I conclude our work. The conclusions of our work are as follows. Propose the first prompt tuning framework for GEM. Develop the lightweight self-training to improve the performance. Prompt tuning has huge potential. Many tasks in data management can rely on prompt tuning or up-to-date instruction tuning to improve the performance. Thank you for your listening.